All right, hello everyone, and thank you for joining us for this Cassandra lunch, the 62nd one. We've been doing this for over a year now and look to continue. Today we have a guest speaker, Sarma. He's a principal database engineer at Verizon Data Services, and he's going to be presenting on Grafana Dashboard for Cassandra. We appreciate him taking the time to share some knowledge with us. And the organizers for this event are Raul, Arpin, and myself. We're always looking for more guest speakers or sponsors. So if, like Sarma, you feel like there's something you want to share with the rest of the Cassandra community, definitely reach out to one of us. Our emails are listed there.
Hi, good afternoon, everybody. Can you hear me okay and you can see my screen?
Yep.
Okay, perfect. Thank you very much for the opportunity. Thank you to Anant for hosting me today or giving me this opportunity to talk. Thank you, Josh, for arranging everything and coordinating. Thank you, Rahul. You always are the great speaker. So I'm sure this was my request that September 1st, Spark Cassandra connector push down. I requested a couple of weeks ago and Rahul considered it. Thank you. Thank you for that. So let's see the topic of Grafana dashboards. About 7 months ago, I was looking to see how we can visualize the Cassandra Matrix on Grafana or any other visualization tool. Especially, I wanted to keep it all open source, and then I started looking at different options available. So first, I'll show you what was the problem of existing dashboards, because please don't get me wrong, there are several dashboards existing. So I will explain what is the issue I saw with them. So just to quickly list out, right, the existing Grafana dashboards were built by several people. There are like approximately 10 of them. They are old, built on old Grafana versions, and the latest Grafana versions had those dashboards broken and they're not working well, or pieces of the dashboard is not working. Now, all of the existing dashboards or the Grafana technology behind that, they use Cassandra's JMX to get the metrics out of Cassandra. And that means they provide you with a jar. And I personally, I don't trust any of these third-party jars, which are built by some other people. It's a Java code which plugs into our production database. I'm not comfortable doing that. So since I don't understand JMX, and JMX is a horror story for me, I'm not a Java developer, and I don't trust putting somebody else's Java compiled code into my production cluster. Um, I felt this JMX with jar plugin was always complicated, and I did not trust the process. So just to show you, let me go to Grafana website. Now, for the Josh mentioned about the question and answers, my presentation approximately takes about 20 minutes. And if you have any questions, we can definitely discuss right away. We don't have to wait until end of it. So I'm on grafana.com. Generally, if you have to look for dashboards, you go to Grafana, look for dashboards. I'm going to select filter out by using keyword Cassandra, and you see the filter out came out, and then there are a bunch of existing dashboards. You can see approximately 10 of them. I'll randomly pick one of them here. And what it does is basically, you can see this was built 2 years ago. I have not personally tried it, whether it works or not, but I'm sure it uses the JMX exporter. So you can see this. What it means is basically they will provide you with a jar. You will download that jar and put it on your server. And I personally I'm not comfortable with this process. So let's see how I was thinking in those days, like 7 months ago, and I tried to solve the problem using something else. So mainly, I don't want to use JMX, meaning JMX is there in its place. I'm good with it. I'm not going to touch it, configure it, or change the security settings with JMX. All that is a horror story for me. So no JMX in my solution. Then the next thing is I would like to use Prometheus Grafana latest versions and make sure I use the basic stuff so that it is not broken when the Grafana releases a new version. We don't want our dashboard to be broken, um, which is also one of the issues with the existing dashboards. They wanted to use all these fancy plugins. And at the end, when you upgrade your Grafana, basically you don't want to break your dashboard. Meaning, I don't want to go back and recreate the dashboard with the new version and test it all over again. And my solutions usually I want to keep it simple. If something can be done with shell scripts, because shell scripts we can understand its source code, we can look at it. I want to keep it simple. And that is the same methodology I have used in the Grafana dashboard. It looks neat and clean. And obviously, I put together something I think is interesting, but people can come in and contribute and make it look better. Um, in a minute, I will show you how the dashboard looks like. But what I want to show you is the architecture of how I was thinking and what I created. So if you see here, we have three node Cassandra cluster on the top. Each node will have node exporter, which is a Prometheus component, which collects all the metrics from the node and publishes them so that Prometheus server can scrape through those metrics and put them in its time series database. You can also see that on each node, I have a shell script, and that shell script is basically taking all the Cassandra metrics. In next few discussions, I'll show you how those metrics are extracted. But that shell script takes those metrics and converts them to Prometheus format so that they can be submitted, or what you say, presented to Prometheus for monitoring. Now, for monitoring part of it, we can have Prometheus Alert Manager. In this project right now, I have not finished configuring the Alert Manager. That is one of the pending tasks. But since Prometheus comes with the Alert Manager plugin, it is easy to use this infrastructure. And I have seen a lot of people in a lot of organizations, they already have Prometheus and Grafana. So it will be easier for them to convince to use this dashboard for Cassandra. The last layer you see is the Grafana dashboard itself, and we will practically see how it looks like. So first thing I want to mention here is if you look at Cassandra's documentation, I'm on the operating metrics page of Cassandra. I went to the Cassandra documentation and look for operating, and under that there is something called metrics or monitoring. In that specific location, you can see Cassandra is built using drop wizard metrics, or basically Cassandra can publish all these metrics using drop wizard metrics library, and they're available via JMX. Now, JMX is the default option, but there is another small setting which you can configure in Cassandra to make it available as a plain text file, meaning all the metrics which are available via JMX are also can be published using a plain text format, and that can be configured when you setting up your Cassandra, or later on you can configure. We can look at, so I have published all this project on GitHub, and this is the GitHub page. And in the slides also, you'll see the link. So without spending too much time on how to get to the GitHub, what we can look at is the first, the reporter, the metrics reporter. I'm going to increase a little bit of this font so you can read it properly. Now, out of the box, Cassandra, when we get Cassandra tarball, we have a YAML file which provides the sample for metrics reporter. Only thing is it is not enabled. So by default, this particular text formatted metrics are not dumped onto the system files. So what we need to do is to create a metrics reporter.yaml file, put it in the configuration files where the Cassandra YAML exists, and then do some configurations into like Cassandra env.sh, which I'm showing here. So what we'll do, we'll look at these files on the server. So if you see this screen, I'm connected to one of my cluster nodes, and this is a 3-node cluster. I'm running 4.0 beta 4 on this cluster. And what I'll do is I'll just quickly go into the config folder, and I will just list out all the files here. And you can see, for example, we are looking for the Cassandra Matrix reporter. And here is the sample file which comes with the, by default, it comes with the Cassandra package. What I did is you can actually read through this config file. It is pretty straightforward to understand. I took the same sample file and created my kind of metrics, what I want to capture, and put it in the metrics reporter.yaml file. This file stays in the same config folder where all the Cassandra YAML files are. So if we quickly look at this file, what it looks like is basically, so ignoring all the header or the commentary, you can see that it is going to output a file, which is a text file. Basically, we are taking all the Cassandra metrics and writing it into a text file. Now, we are not plugging in any jar. So I'm not worried about somebody else wrote Java code. I'm plugging it to my server. This comes out of the box with Cassandra. So I'm just using Cassandra. Hey, can you dump this metrics into this text file? And you can also configure at what is the frequency of this metrics update. I have played with different settings. And what I see is if at all your table size changes, right, you don't need to see it every 5 minutes. That I thought is too much metric collection. So I looked at different settings and I said, okay, every 15 minutes, if Cassandra tells me this is your table size, that should be good enough for me. But again, as I said, this period is just configured in this text file. You can just modify the period into like 800 seconds or 500 seconds, whatever suits your requirement. Then ignoring few of these settings, you can see here all these entries are telling what kind of metrics you want to dump into this text file. Now, one other issue when you use the JMX or anybody wrote the jar file is they might be dumping so many metrics which we don't need to look at, and it just overwhelms the whole monitoring suite. So whatever mechanism you use for monitoring, sometimes we don't want to see all the 1,000 metrics. We want to focus on what we need. And I started with this simple metrics, like some of them are related to commit logs, some of them are table sizes and key space sizes. Some of them tell me about the SQL statements, and some storage authentication related stuff, latency. Um, Again, as I said, these are not limited to these metrics. All the metrics you can capture from Cassandra are documented on the Cassandra documentation page. You can see if you read through this, these are all the metrics you can actually capture and send them to the text file using this method. So remember that you can take Cassandra metrics and publish them using JMX, and that is the JMX MB in here. Or you can use this particular string here to publish the same metric into a text file. So what I'm doing in this method is, without using JMX, I'm just telling take all these metrics and dump them into a text file. Now, what we can do is quickly take a look at this text file. We don't have to read through the whole thing, but I'll just do a tail of 100 lines, let's say, from this file. So you can see, for example, it writes in a specific format where it says, ignoring the package name here, what it is a table write latency. The table name is keyspace.table name format. and it tells me what is the metric like count, mean rate, 1 minute rate, 15-minute rate, and so on. So it writes a text file. Every 15 minutes, this text file will be updated with the latest metrics Cassandra will dump into the text file. Okay. So that is how we extract the metrics from Cassandra without using JMX or any jar files. Now, remember one more thing I mentioned is by default, this method of extracting metrics is not enabled, meaning we have to add one line into Cassandra nu.sh file. And this is the last line I have added in this file. So you can see, for example, let me do one more thing here. Instead of doing it this way, I'll just say tail minus 2, maybe tail minus 5. Okay, so in Cassandra nu.sh file, we need to specify that I want to use the metrics reporter, and I'm specifying what is the configuration file Cassandra will use while starting up, and it will start dumping this metrics into the text file, which was pre-configured in the metrics reporter YAML file. Okay. So this is the configuration which enables when you restart your Cassandra on this node, it takes the metrics reporter plugin and enables it. As well, it uses the configuration file and starts dumping those metrics into the text file. Okay. That is the avoiding JMX part of it without plugging any external jars into the existing Cassandra and publishing the metrics into a plain text file. Okay. Any questions at this point? So I will take that as a no.
Hey,
Yeah, go ahead.
hey, Sarma. Yeah, Sarma. Yeah, thanks. I, uh, I remember trying to do this with with JMX term and export values. I'm curious, and I know Drop Wizard, right? It's always collecting the metrics, and so we're just mentioning it to drop it every so often. But like, do you notice any, even if you do it every 15 minutes, like, do you notice any hiccups in performance, or like, is there like a compute cost or a memory cost for doing this every 15 minutes?
So I'm using it in production, and I have about 80 nodes in my production and non-prod. Personally, I have not seen any problems with it, meaning I haven't got any complaints from the user community saying, hey, at every 15-minute, our Cassandra
Right.
is not performing or things like that. What I would like to do is have many more people use it in different environments, because my
Mm-hmm.
environment might be tuned in a specific way, and I might not notice issues with this. But at least to keep it simple, right? I did not get any performance related issues with this. And I believe if you go with a cron job every 15 minutes, ask JMX to give you metrics compared to what we're doing here, should not be different. So
Yeah.
I wouldn't expect issues with performance, because Cassandra is built with this, and this plugin already comes with it. So okay, I haven't noticed any issues. Maybe if we have more people use it, maybe we might see something.
Yeah, I imagine if you added more metrics and more frequently, you'd probably notice it. But GMX is definitely more costly in terms of CPU and memory. It, especially if you do it from an external tool like GMX term, it definitely takes more power. So I imagine this is probably much more efficient anyways. Thanks.
Yeah, so the other way to ask is basically, I don't know how to measure performance for this. So maybe we can have somebody else try it out and let us know how to measure that performance. Okay.
Right.
Yeah. Perfect. So now that we have our configuration done from Cassandra side of it, meaning Cassandra is able to take the metrics and dump it into a text file, we move on to the next step. Okay. So what it requires is basically you configure this on Cassandra, every node on Cassandra cluster, and restart Cassandra so that it starts dumping the metrics. Now, next part will be, obviously, we have to give this matrix to node exporter. Now, node exporter is generally used for collecting all the OS metrics. What I'm doing here is I'm not collecting all the OS metrics using node exporter, but I'm just publishing the collected metrics in Prometheus format, so Prometheus can scrape that metrics. So what I can do is I can just quickly jump into Prometheus. This is how my Prometheus looks like. You can see here there are 3 servers configured on Prometheus. Let's just randomly pick one and look at what it is publishing. And if you look at this matrix here, so this is how a node exporter Prometheus metrics look like. So initially you will see on the top, it is all like, Prometheus related stuff. The node exporter is telling I was able to run this job in certain time and whatever it is doing inside. And then you can see here node exporter build info, which tells you how it was built, what version it is running and stuff like that. Then um, I'm going to talk about the shell script, which converts the Cassandra matrix into specific format. We haven't got there yet. But what you can see here, if the node exporter was able to take the text file and present it to Prometheus properly, if there was any error, it will show up here. And also you can see in this particular matrix, you can exactly see what is being collected, which I think it will be hidden if you're using that JMX and jar methodology. We don't know what metrics are being collected. Like, from my server, what are you collecting? I don't know. So in this case, you can actually look through this matrix and make sense of what it is collecting. Let's say, for example, we just look at one of the entries here. It says commit log size in bytes, and the cluster name is so and so, data center is so and so, host name is so and so, and then it gives the number of bytes allocated for commit log. So if I randomly pick another metric here, see here, this one says mount point used percentage, and it tells you that the root mount point was used like 5% usage. And since these metrics are published in plain text, we can actually go through this metrics and understand what they're doing inside, meaning what metrics are being published without having to worry about it is publishing too much information or too less information. My point is here is that it's plain text, so we can read and understand what we are publishing to Prometheus. So now that if you ignoring the shell script, if you think Prometheus is able to get that metrics, we will be able to use Alert Manager for sending alerts, which we are not discussing today because it's not configured in this project yet. But I can jump to the Grafana dashboard to show you how this dashboard looks like. So first thing what I did here is on the top, if you see, you can actually pump metrics from several different Cassandra clusters, and you can have a filter here. All the metrics are displayed for a specific cluster. So here I have HZD cluster, that is my cluster name. And if you are wondering what HZD means, it is Horizon Zero Dawn. It's a PlayStation video game. I'm a gaming addict, so so that is my cluster name. Now here you can filter based on data centers. I have other options like you can filter based on the host names in that data center or in all data centers in your cluster. You can also filter by key spaces and table names. Later on, we'll look at some of the metrics which are key space size or table latency. You can actually put filters here. That way you see what you're interested in. Let's say, for example, you have a transaction table which is always busy and you want to see what kind of latencies you're facing. Let's say I'm going to pick 2 of them here just for fun. We are doing some filtering here. Now I'm going to reduce this size a little bit, and then we'll talk about some of these metrics. When I was building the Grafana dashboard, okay, so remember that my job role is I'm a database administrator. I work on Cassandra and Oracle, and I have no clue how Java code is written, and I don't know Prometheus Grafana. So this was all a learning curve for me. But when I was building my Grafana dashboard, I just did not want to slap like many graphs on screen and say, then people don't look at it because it doesn't make sense, right? There is all the, it creates more confusion than clarity when you put like 1,000 different graphs on one screen. That's how Ops Center looks like. Sorry to say. So um, what I did here is I separated each of them into subsections. And here you see the system summary basically tells you what operating system you're running, RAM usage, CPU usage, a quick summary of how many servers are in your cluster. Then it also has a view for storage. On this cluster, I'm not using too much of storage, but there are two views here. One shows how much mount point is used and how many inodes percentage used, because we have seen that there are sometimes inodes take up too many inodes, and you might have to solve some, clear some inodes and all. So I wanted to show the two metrics in the system storage related section. Now, without spending too much time, this is how your CPU and RAM usage looks like. This is from the overall server perspective, nothing to do with Cassandra memory. So it just shows you where the CPU spikes are and RAM usages. And you can definitely click on one of these servers here to change the graphs and show only specific server. That's all Grafana. I'm not doing anything special for that. Now, let's jump into the Cassandra metrics. I definitely wanted to show this view, which basically shows how many nodes are in a cluster, how many are up, how many are down, how many data centers are there, and then show how many nodes in each data center. So that is a nice view where you can see one view which tells you how many nodes are there. I wish I had a larger cluster to show you, but it looks neat when you see a larger cluster. So let's look at the next one. Is just like the system summary, I wanted to build one summary for the Cassandra itself. So this is Cassandra view, this is the node, and what version of Cassandra we are running, which data center, what is the rack name for the node, how many tokens each node is handling, what is the uptime. Obviously, if you restart your Cassandra, this uptime will reset to 0, and then you will see that thing go up just like system uptime. And also it will show you like 5+ minutes when it is in minutes. And when it becomes hours, it shows 14+ hours. And then it becomes days, then you will see 1+ days, something like that. Now each node is handling certain amount of data, and you can see that data repair percentage is also displayed there. Now the storage errors, we definitely don't want to see the storage errors, and I personally don't know what kind of storage errors can occur. But there was a metric which I wanted to visualize, because what if there was some error which I don't know about, but it will display here, and then we might want to dig into why it is happening. At this point, for about 3-4 months, I have never seen any storage errors, which is good. But definitely someday we'll see it and we might have to dig into it. Now, this is the Cassandra Heap or the JVM. We are using the heap memory, and we also know that Cassandra uses off heap. So I tried to put that in a nice graph here, which shows that how your GC is happening. And if you notice, let's say, for example, if we look at one server here, if you see this particular metric, I can approximately get a view that every 20-25 minutes you are having a GC. So whenever GC is running, you know that GC pause can happen, and that could cause issues. And if at all this graph shows like, every 5 minutes you're having GC, every 3 minutes you're having GC, then that's not good. So that's the reason I wanted to put a graph here which shows how your GC is happening and how the heap is being used. So it goes up to certain limit and then drops down and then starts to grow again. Also, it has some text metrics, like say how much heap is allocated, how much is used, and then used percentage. And then also it shows off heap used. So some of the Cassandra objects can sit off heap, and we can get estimate of how much off heap is used using this particular metric here. So let me speed up a little bit. We know that key cache, row cache, and counter caches are there. Row cache is by default not enabled. So if you enable, it will show up. But you can see here key cache, we are pretty much at like, 80+% of hits, which is good. We don't have too much of misses. And this gives us an idea of how the key cache is being used. Then I have some metrics collected for the query language. So any SQL queries running, you can see how many are cached and how many unprepared versus prepared statements are being executed. Generally speaking, any application, we want more prepared statements. On this particular application, I'm at 99% prepared statements, which is pretty good. And there must be some random queries running which are unprepared. So this gives a very good view of how your prepared versus unprepared statements are in the cluster. Then we can look at commit logs. We don't want any commit logs to be in a pending state, meaning any tasks pending for commit log writes. We generally want them to be 0. And that's the indication in the first column here. And then you can see completed tasks. Actually, for me, it doesn't really mean anything. There are a million times commit logs were written to, doesn't mean much. But it also gives you a view of how is the size on disk for commit logs is per node. You can also see the clients and hints is the section where, say for example, if there was a server down, there were pending hints to send. That means one of the server is holding the hints for another server. You can see that hints here if it is sending anything in transition. And also you can see the client authentication success and failures. Now, if you had some failures, obviously there is an application configured with wrong password connecting to Cassandra and it is failing, you definitely want to know that there are some failures. Some of this information is available in the syslogs and the debug logs, but it is just very difficult to see them because if you use Grafana kind of application, you can visually see them in one place. So that's about the clients. So this is one more section where I wanted to show if there were having client timeout, client request timeouts, like whether it is read timeout, write timeout, range timeouts, or whatever timeouts happen. Now my application is running very well here. So obviously we don't have any metrics here. Now there are table latencies. This is one thing I could not understand, but I definitely wanted to show it, meaning someday I will understand and crack the code behind it. So when I'm writing data into the node, it has that node write latency. Same thing with coordinator write latency, and this can be this is visible by the table name. So you can actually look at one specific table how it is performing across your cluster. And you can see how many events happen, how many times these events happen. Graph itself is cumulative, meaning it keeps growing. When you reset your Cassandra, this metric goes 0, and then it starts to see this latency. At this point, I don't have explanation of what that latency means, but at least I wanted to put the metric here so we can dig more into it. Then there are two small views here, nice views, which show you the key space size. So you can go by the key space or you can look at by the table size. But here I'm showing key space view. And this by default excludes all the system key spaces. It only shows the user key spaces. And then system, again, this is a tables view. So in each key space, we have multiple tables and it shows the table growth. Unfortunately, here we don't see much of growth because this is over period of 3 hours. You can actually increase it to, let's say, for example, period of last 24 hours. And you can see a little bit of growth if you change the timeline. So that's how the Grafana dashboard looks like. And then let me quickly jump back here to GitHub and show you how you configure that. Okay, so we talked about metrics extraction from Cassandra into a text file. We talked about the node exporter, which basically takes the text file and publishes it to Prometheus, and all the configuration is displayed there, how to configure it. Now, the one piece which is kind of mystery is the shell script. What shell script does is, you saw the metrics text file. That text file needs to be converted into a specific format so that we can present it to Prometheus. So this shell script actually takes that and does this task of converting the text file and collecting some other metrics, putting them like, in a proper format. And if you look at the shell script, let me just open it in raw mode. So this is how shell script looks like. It is not a very large shell script. I think it has like 200, 300 lines of code. It's a simple bash script. It collects different metrics and puts them into specific format so that we can present it to Prometheus. So what it does is, using a cron job, every now and then, basically on the cron job schedule, it takes the system metrics and it collects some of the mount point related metrics, converts them into a specific format, and then also adds all the Cassandra related metrics into Prometheus format. Okay. Since this is all open source, anybody can look at this code, and if they have to contribute, if they have some updates, it is easy to update this compared to somebody else wrote the Java code, which I don't understand. So this is the shell script, which is also available on GitHub. This shell script is what I was showing you in the architecture diagram earlier. So let me go back to here. This is the shell script here with every node. And now at this point of time, we covered all these small components within this dashboard. These are different views of the dashboard, how they look like. And you can see the PlayStation PS1, 2, 3, 4. This is the GitHub link, and you can make a note. And basically, I have some other projects also published on GitHub. Take a look at them. And at this point, I think we should mention one extra thing is, there is a lot of confusion about the Grafana Cassandra plugin. Now, there is a project called Hades Architect. This is done by Alex at DataStax. This is a Grafana Cassandra plugin as a data source, meaning this is used for taking your Cassandra data, user data, and visualizing it in Grafana. This has nothing to do with Cassandra Matrix. Okay. I would like to mention one more thing is, there is another DataStax open source project called Apache Cassandra Matrix Collector and MCAC, and that one is broken. Their Grafana dashboard is broken. So anyway, what I did in the past 6 months is basically put together a dashboard which I like to use, and I want to see if more people like to use it. It is mainly, there is no JMX, and it is easy to use. Once you have everything set up, the dashboard you saw looks pretty straightforward and clean. And just for fun, I wrote one extra instruction for JMX. That's how it looks like. So that's it with my presentation. Now, there was a question on the chat. I just want to answer this question. Pramod is asking if there is any setting for retention policy for the generated text file. I'm guessing that is what we are using from Cassandra metrics, which are dumped into text file. What we noticed is it can quickly become very large, the text file. So what I did in this shell script is, every night there is a cleanup which is happening on the text file. So what it does is, between a specific time here, it will clean out all the metrics and make the the input, what you say, matrix file to null, meaning it just becomes 0 and then restarts again. Now we might have a question of, oh, what if we want to retain some metrics? Remember that Prometheus is keeping all the historical values, historical metrics. So we don't need to keep them on the Cassandra server itself. Okay. Pramod, does that answer your question about the retention for the metrics? Yeah. So this was taken care in the shell script, but you can do other things, maybe a better thing to do. I just came up with this logic, but there can be a better method to do it. Yeah, so one mention about this whole stack I built here, right? The idea is this works with DataStax product also. And the other thing is this is all open source. So there is no licensing cost here. So I have seen people build their Cassandra clusters with open source and they're not paying any money for their software, but then they use New Relic for monitoring it, where New Relic is expensive. So if you want to monitor your cluster, which is open source, you're not paying any money to store your data. Why pay money to monitor it?
Awesome. Thank you. Thank you, Sarma, for presenting. Really good information here. And yeah, that'll pretty much wrap it up for us, you guys. Really good discussion from Sarma. Good questions and explanations. Thank you.
Thanks, guys. Thanks, Irma.
Thank you.